Lesson 8. Finding areas. You need to know how to find areas under curves using the integration techniques learned in this chapter. Let's do some examples. The diagram shows the curve y is equal to 9 over the square root of 4 plus 3x. Use the integration to find the area under the curve from x equals 0 to x equals 4. We know the area under the curve, A, will be equal to the integral from 4 to 0 of 9 over the square root of 4 plus 3x with respect to x. Now we can rewrite this as 9 lots of the integral, we can bring the 9 out, of 4 to 0 of 4 plus 3x to the negative a half dx. Now we can use the reverse of the chain rule. If, for instance, a y was 4 plus 3x to the half, where we increase the power by 1, then dy over dx would be a half, bring the power down, 4 plus 3x, reduce the power by 1, minus a half, which we want, but then multiply by the derivative of 4 plus 3x, which is 3. And so you'd get 3 over 2 lots of 4 plus 3x to the negative a half. But we don't want a 3 over 2, so we're going to multiply by 2/3. 9 multiplied by 2/3 is 6, and so a is equal to 6 times the square brackets of 4 plus 3x to the half from 4 to 0. And this is going to be equal to 6 lots of 4 plus 3 times 4 to the half minus 4 plus 3 times 0 to the half, which will give you 6 lots of the square root of 16 minus the square root of 4. The square root of 16 is just 4, and the square root of 4 is just 2. 4 minus 2 is 2, multiplied by 6, and that gives you 12 units squared. The area between two curves can be found via integration. If you have the functions y equals f of x and y equals g of x, where f of x is above g of x, then the area between them from b to a will be equal to the integral of f of x, the top function, minus g of x, the bottom function, which is also equal to the integral from b to a of f of x, the top function, minus the integral from b to a of the bottom function, g of x. This only works when the two curves don't intersect between a and b, where y equals f of x stays above y equals g of x at all times. Let's do another example. The diagram shows the curves y is equal to sine of 2 of x and y is equal to sine x multiplied by cos squared of x, for 0 is less than or equal to x, which is less than or equal to pi over 2. Use integration to find the shaded area. Using the rule we just learnt, the area will be equal to the integral from pi over 2 to 0 of the top function, sine of 2x, minus the bottom function, sine x multiplied by cos squared x with respect to x. Now, using the integration techniques we've learned, the integral of sine of 2x will be negative a half cos of 2x, and using the reverse of the chain rule, the integral of minus sine x cos squared x will be plus a third cos cubed x, because a third cos cubed x will differentiate into minus sine x cos squared x. And so this is from pi over 2 to 0. This will be equal to negative a half multiplied by cos of pi, which is minus 1, plus a third of cos of pi over 2, which is 0 cubed, minus negative a half multiplied by cos of 0, which is 1, plus a third times cos of 0 cubed, which is just 1 again, and this will give you 2/3 units squared. You can use integration to find the area under parametric curves. It's usually easier if you integrate with respect to the parameter instead of converting to Cartesian equation, like in the next example. The curve C has parametric equations x is equal to t multiplied by 1 plus t, and y is equal to 1 over 1 plus t, for t is bigger than or equal to 0. Find the exact area under C from x is equal to 0 to x is equal to 2. We know the area A is equal to the integral from b to a of y multiplied by dx, but using the chain rule, if we want to integrate with respect to t, the parameter, this can be rewritten as the integral of y multiplied by dx over dt with respect to t. And we can integrate using this. We know x is equal to t multiplied by 1 plus t, which is t plus t squared. And so dx over dt will be 1 plus 2t. We need to adjust the limits to make, instead of from x from 2 to 0, we need it in terms of t. So when x is equal to 0, that means t multiplied by 1 plus t will be equal to 0. And this means that t is equal to 0, as t cannot be equal to negative 1, as t has to be bigger than or equal to 0. When x is equal to 2, that means that t plus t squared is equal to 2, which gives the solutions t is equal to 1 or t is equal to minus 2. But t cannot be equal to minus 2 because t has to be bigger than or equal to 0. So t is equal to 1. And so therefore we're solving the integral from 1 to 0 of 1 over 1 plus t, which is y, multiplied by dx over dt, which is 1 plus 2t, with respect to t. And if you have 1 plus 2t over 1 plus t, after dividing, you get the integral from 1 to 0 of 2 minus 1 over 1 plus t with respect to t, which gives you 2t minus the natural log of 1 plus t from 1 to 0, which gives you 2 minus the natural log of 2 minus 0 minus the natural log of 1, which is just 0. And so all you're left with is 2 minus the natural log of 2 units squared. And that's about it.